In this video, we're going to look at the concentration unit of mole fraction. It's symbolized by capital X, and A just means the same. It's basically what the numerator is. Okay, so the moles of substance A over the total number of moles of solution gives you the mole fraction. And there's no units because moles divided by moles cancel each other out. So this is a very simplified example of a box with different numbers of the different letters. So if I count, I've got 1, 2, 3, 4, 5, 6, 7 A's. And to save myself some time, I've made a list here of what those are. Okay, so simply, if I want to do this, then I basically would take the fact that the mole fractions of A are the 7 divided by, I also added all of these up to equal to 24, and that gives me 0.292. Again, there's no units there. The mole fraction then of B is the number of B, which is 6 divided by 24, and that's 1/4 or 0.25. The mole fraction of C is 5. There's 5 C's in this box. Divided by, again, the total of 24 gives me 0.208. And the mole fraction of letter D is 6 again, divided by the 24 to be another 0.25. The other thing about mole fraction is the sum of the mole fractions has to equal 1. So when I add 0.292 plus 0.25 plus 0.208 plus 0.25, I end up with 1.00. And so this is the total mole fraction. And it's kind of a check when you're doing problems to see if you've got them correct. So now let's apply that. So in this problem, it says, what is the mole fraction of glucose? So it's asking for the mole fraction of glucose that I get by mixing 218 grams, so grams is a unit of mass of glucose, I give you the molar mass of glucose. So the molar mass of glucose is 180.2 grams per mole. And 460 grams, so I have again a mass, this time it's of water, is 460 grams of H2O. And I have a temperature of 30 degrees C. I don't need the temperature of that. And then also at the end asks, what is the mole fraction of the water? So the mole fraction of the glucose is going to be the moles of glucose over the total moles. So I have to first find then the moles of everything that's in here. So this is a simple one, which is what we're going to be working with, which is a 2-component solution. And so the first thing I need to find is the moles of glucose, which is mass divided by molar mass, which in this case is 218 divided by 180.2 to give me 1.210 moles of glucose. I need to do the same thing for water. I need to find the moles of water, which is going to be the mass divided by the molar mass. The molar mass of water I didn't give you, but it's 18.02. So therefore it's going to be the 460 grams divided by the 18.02 to give me 0.53 moles of water. So my total moles is going to be the 1.210 from glucose plus that of 25.53 moles of water to give me 26.74 moles. So going back to this now, the mole fraction of glucose is equal to that 1.210 divided by 26.74. And that gives me 0.0453. Now, for the mole fraction of water, there's two ways I can do it. Okay, I can do it the same way I just did. Mole fraction of water is the moles of water divided by the total moles, which would be the 25.53 divided by 26.74 to give me 0.955. Again, there's no units for that. But given the fact that the sum of this mole fraction has to equal 1, this is only a two-component system, I can also say that the moles of water is equal to 1, because it has to add up to 1, minus that 0.0453. And when I do that, I still get 0.955. Okay? So that's how you can do that. All right, I'm gonna stop this video, and I'm going to do another example in the next